Okay, so here's the deal. Let's go ahead and model these graphs, okay? So I want to show you guys how to look for them. So the first thing we always got to focus on in any quadratic, guys, you always want to get y by itself. You always want to solve for y. All right, most of them are in that ax squared plus bx plus c form. But if the quadratic's not, you can take it and get it for y by itself. All right, so that's the first thing I got to recognize. Not all of them are with y by itself. So remember, x is your input, right? And what's y? If it's a function, y would be your output. So you could write that as f of x equals ax squared plus bx plus c in that form. Okay? And so when we graph these, you always want to produce that y equals form. Okay? And then we always look for two aspects. We look for the axis symmetry on the parabola, so where it folds in half, and we also look for that vertex, just like we showed you on your warm-up today. Okay? And so then we can use our graphing calculator to plot the characteristics of that graph. So here we go. Here is a simple quadratic equation. Okay? On your graphing calculator, I want you to type it in. Very simple. Okay, so we're going to go to y equals, and I want you to type in 4x squared minus 7. Go ahead and do that right now. Everyone needs to do this right now. Type it into your calculator. All right, and then you hit graph in the upper right-hand corner. There's your graph. How long did that take you to do? Yeah, a little. So that's where technology comes in handy, guys. Okay?
Why does mine look completely different?
Yeah, it's nice to make a table.
Mine's empty.
Okay, so if yours is acting up, here's what you can do. No, pay attention, guys. If it's not popping up, you go to second plus,
Oh, what the heck?
hit second and plus. This screen pops up. Hit option 7, reset. That'll reset your calculator to the factory
Wait,
settings.
this is RAM
Yep.
archive all.
So you're going to select option 1, all RAM, and then hit reset option 2. So it'll go back to factory settings. Okay?
Press alpha F1.
And so we can do, so now when you go back to this, you could retype it in. Okay? 4x squared minus 7. Okay? So now we know how to use our calculator. We know how to reset the memory if that
It's still
happens.
pointing down.
Okay. So what issue are we having?
My graph is like this. I put 4x squared minus 7.
Okay. Let me see it. Okay. You guys, this is kind of basic. This is 101.
No, I didn't. I hit 4x squared.
We got to know how to use our calculator, guys. I'm making this so simple.
Oh.
Okay? That's all you're doing, right? So we hit graph. There's the graph of it, okay? So all you do is you recognize, hey, my table comes right off of that calculator by hitting second graph. So hit second graph. Now you got your table, all right? So all we do is create a little table. And we copy them right off our graphing calculator. Okay? So you'll see what some neat things about this, guys. You'll see if you use the Fab 5, you're pretty safe. Okay? So what do I mean by the Fab 5? -2 to +2 are the Fab 5 you typically want to stick with. Okay? So all you do is you look at your graphing calculator and you look at where is -2. Oh, for -2, my output is 9. So there's my answer for the first point. Okay? And then at -1, I get -3. 0, I get -7. 1, I get -3. And 2, I get 9. So you can literally do these in no time, guys, if you recognize how to use technology. Okay? So all you do is plot those points on the graph. -2, up 9. There's my first point. Negative 1 up 3. 0 down 7. 1. Let me make sure I got this right. So 1, actually was 1 negative 3?
Yeah.
Yeah, 1 was negative 3. Make sure I got that correct. Negative 1 was down 3. That was correct. So, this one's wrong. My bad. At negative 1, I go down 3. There we go. So we got that correct now. So it's all mirrored across. And then over 2, up 9. That's right there. Okay? So here's your parabola. It goes right through those points that your calculator gave you. No thought involved at all. All it is typing it in your calculator again. Okay? And what we'll see here is where's the axis of symmetry at for this one? Yeah. So the axis of symmetry would be at x equals 0. That's that vertical line. Alright? And where would the vertex be at? So let's jot that down. The vertex is at what coordinate? 0, negative 7. And you're done. Okay? Now, I do want you guys to appreciate what the calculator is doing for you. Okay? I want you to understand where these are coming from. Alright? So what does the x represent again? And what does the y represent? Output, right? So I want to show you how to get one of these ordered pairs if you didn't have a graphing calculator. Okay? So all you would do is you would plug in negative 2 for x and evaluate the y. Okay? So what's negative 2 squared? 4. What's 4 times 4? And 16 minus 7. So what's 16 minus 7? 16 minus 7? 9. See that? So what was your y value when your x was negative 2? 9. So you're seeing where those are coming from, right? If I took the next point on my table from my calculator, and I typed in negative 1 for x. Let's do it one more time so you get appreciation for it, right? Negative 1 squared is? Negative 1 squared is? 1. 1 times 4 out front is? 4. 4 minus 7 outside? Negative 3. What's the y value when x is negative 1? Negative 3. Okay? This is how we used to have to graph with no graphing calculators. Alright? So you would get good with your arithmetic. You'd know how to multiply, use PEMDAS to get your outputs. Okay? So I want you guys understanding as a function notation where they're getting those from though. Okay? Even though you will be allowed to use a graphing calculator, it's important to see that. Okay? Alright, let's take a look at another one. Here we go. We have a quadratic equation. We're going to graph. Okay? Alright, so first thing we're going to do, before I even graph this, let's go ahead and, we recognize y is by itself, right? So that's good. Guys, pay attention, please. Okay? See how y is already by itself? So you're good. Alright? So let's find the axis of symmetry just by doing it algebraically. Alright, so how do you get that axis of symmetry? So you label the A, B, and C to start, right? And what was that formula? Negative B over 2 times A. Okay, so what goes on the top, Haley? Negative B, so what would that be? Negative 4, right? All divided by 2 times 2. Okay? So what would that be? Negative 4 over 4, which is negative 1. So that's your axis of symmetry. So here's what we're going to do. I just want you to go ahead and just create your own little graph right here. We'll just sketch it on the side. Alright? And we'll draw that axis of symmetry. Okay? So that's going to be right through negative 1. Vertical line. So there's x equals -1. So a lot of times you can tell right from the equation where the axis symmetry is by using that little mini formula I gave you. Okay? Now, can you guys tell me if this is going to open up or down? It's going to be an up parabola because the A is positive. Very good. So that's important to recognize. The only other thing we need is the vertex. So why don't we make our lives easy and type it into our graphing calculator. Yeah. So here we go. Type it into your graphing calculator right now. Okay. 2x squared plus 4x plus 3. Okay. And then what we're going to do is hit graph in the upper right hand corner. So go ahead and do that right now, guys. Type it into your graphing calculator. Actively do it so you'll be able to get these on your own. Okay. And then hit graph in the upper right hand corner. Hopefully you're getting this same graph. Alright, raise your hand if you're getting that same graph that I'm showing there. Alright, good. You know how to use your calculator. That's good. And the vertex is pretty obvious. That's the turning point of the parabola, right? So you can see, sometimes you can even see right on it. You can say, wait a minute, if I look at the table, my low point at -1, my output is 1. You guys see that? So what's the vertex going to be at? -1, 1. So you already know the vertex is at -1, up 1. So I go left 1 and up 1. There's my vertex. Okay. Now another thing, a smart thing to do when you plot your graph is just to pick a few points left and right of the axis of symmetry. Okay, so I'm going to pick, like, yes, we want to stick with the Fab 5, but I always tell students maybe like 2 points left and 2 points right of the axis of symmetry is pretty consistent. Okay, so like I would choose like -2 and -3. So let's just pick those two x values left of the axis of symmetry. Okay, so what's my table showing me, guys? So at -3, what's your output? 9. Okay. At -2, what's your output? 3. Alright, so you can kind of see that right away, right? And then let's pick a few points right of the axis of symmetry, so like 0 and 1. Okay. And so let's see what our table's telling us. So what do you get for 0, Michaela? So when x is 0, what's y? 3. Very good. Okay. And then for 1, what am I getting? 9. Yeah. So I really want you guys to appreciate that, hey, the calculator is doing a lot of the arithmetic for you. It's just a matter of modeling it, right? So here we go. -3, up 9. So my first point's up here in the corner. -2, up 3. That's right there. 0, up 3. That's right there. And 1, up 9. That would be right there. So here's your parabola, guys. It goes right through those points. You got your sketch. So is this going to be hard to do? No, not at all. I think this might be one of the easiest things you guys have done. All right? Because you're using technology to your advantage. And so I want you guys to see how a lot of times you can get that vertex just from the table. Make it simple. Okay? If you have a hard time finding the vertex, just use that formula. And the x-coordinate of the vertex will be the axis symmetry value. Okay? Alright, I want to see if you can get one of these right on your own. So let's take a look at number 3 here. Okay? And we're going to get you set up first, and then I want you guys to produce it, okay? Alright, what would I do first if y is not by itself? Yeah, you want to get it by itself, so I'm going to subtract the 2x squared to the right side. Okay? So your equation would be -2x squared plus 3x minus 1. Okay? You notice these are not like terms. You can't add them up. So you just write it like that. Okay? Alright, on your own, go ahead and graph this. Graphing calculator, I want the axis symmetry and vertex. Okay? So just type it in, get your components, and voila, we're done. Okay? Very simple. You guys know it's going to go down, right? Just by looking at the negative out front. So it'll be a downwards parabola this time. Okay? Good. Looks like it might not be right at that, so if you're not sure, use the formula. So negative b over 2a, you get the exact value. Okay? Good. So yeah, I'm showing you guys a nice little trick here. You can always get it, and then you can go back and get those characteristics. Okay? So if it's hard to tell from the graph, use the formula, negative b over 2a, to get the axis symmetry. Okay? Good. So 0.75 is the axis symmetry. You just kind of estimate it. You just go straight up towards the line. Good job. Well, you're gonna want all those. The axis symmetry, the vertical, and then all the other points that go on either side. Okay. Well, you're gonna have to plug this into that to get the line. You see how sometimes you have to use a formula? Because the graphing calculator won't give it to you. It'll show the approximate one, but the formula is the easiest sometimes to get. Okay? Good job, guys. Seeing some good sketches. All right, label the vertex and axis symmetry, guys. Try to label the coordinates there too. All right, and you'll get it. Yeah, so plus 3 times 0.75. And you'll be able to get the y value. Okay. Negative 3x squared. Plus 3x. And then minus 23. Okay. Can't, like I said, that's going to make your life way easier, guys, once you see that, which is awesome. Alright, so here we go, super simple here. Here's your equation. You guys typed it in. You typed it in, right? And hopefully you're seeing that it goes which direction? Up or down? Yeah, it goes down, right? So here's what we're going to do. I'm going to show you guys that right away. I'm going to type it into, alright, negative 2x squared plus 3x minus 1 graph. So it goes upside down, and you can see how the turning point is maybe not as obvious. It's like close to 1, but maybe not at 1. So this is a classic example where you might not be able to use your graphing calculator to get the axis symmetry. You might have to use the formula. So we know it's going to be close to 1. Okay? So let's use our formula to get the axis symmetry. Negative b over 2a. So what's the negative b value, guys? So it'd be negative what? Yep, so negative 3. Negative 3 goes on the top. Okay, and then on the bottom, what goes on the bottom? 2 times negative 2. Okay, So notice you're really going to get negative 3 over negative 4, which is 0.75. So if you use the formula, you'll know where it's at for sure. Okay, so let's sketch that. At 0.75, 3/4, there's your vertical line. That's the axis of symmetry, guys. That's where it folds in half. So x equals 0.75. Okay? Now, how are you going to get the vertex? See, the calculator doesn't have, if you look at the table, does it have 0.75 on there? So that's where you have to know how to do it kind of with the formula way, because you'll be able to find the exact vertex. Okay? So all you do is plug that in for x to get the y value of the vertex. Okay, so let's do that, right? Negative 2 times 0.75 squared plus 3 times 0.75 minus 1. Okay? Alright, so let's go ahead and just make sure we get the right value here. Okay? So, Kendall, what would I do in this expression to simplify that then? Do the squared part first. Good. Follow PEMDAS, right? So let's see here. We have 0.75 squared. So let's do that first. And he's hit times negative 2. So that becomes this. Negative 1.125. Okay? Now this part, 3 times 0.75, you just type in your calculator. Notice you get 2.25. So then all you do is add these up for your y value. Okay? So let's do that. Negative 1.125 plus 2.25 minus 1. So you get 0.125 as your output. So the vertex, the actual vertex is 0.75 up 0.125. So you can get the actual value. So we're going to put a dot at that vertex. 0.75, 0.125 is really close to the x-axis. So it's going to be right above that. So that's where our turning point is. Okay? And then all we do is create a little table to get the other points. Okay? So from our graphing calculator, I want to show you guys where those points are going to come from. What kind of points would I want to plug in, by the way, or kind of look for when I want to sketch this? Anything right of the axis of symmetry and anything left. 2 points right, 2 points left, okay? So what are smart points to choose? Maybe 1 and 2. Those are right of the axis of symmetry. You guys see that? What are some points left of the axis of symmetry I'd choose? Brandon, put your phone away, please. Okay. What are some points left I'd want to choose? 0 and negative 1, right? So let's just use our table to get those. Okay. So at 1, my output is 0. At 2, I got negative 3. At 0, I had negative 1. And at negative 1, I got negative 6. So you're done. Just plot those points and you got it. Okay, so 1, 0 is right here. 2, negative 3 is right here. 0, negative 1 is there. And then the last one, negative 1 down 6 is right here. So your parabola looks like this. Goes up through the vertex and back down. Alright, so we're actually making it way easier on you guys because you're not doing much arithmetic. Alright, you just have to recognize the calculator does it for you to get the table. Sometimes you got to find that vertex a little bit, more work to get the vertex, but a lot of times it's easier to find. Okay? So here's what we're going to do.